All right, let's talk AI. For the longest time, the mantra has always been bigger is better. But what if that's completely wrong? Today, we're going to dig into a fascinating research paper that argues the future of AI isn't about these giant, all-powerful models, but something much, much smaller. And to really get why, well, you've just got to follow the money.
So, first up, let's talk about the cash. In 2024 alone, a whopping $57 billion was poured into cloud infrastructure. We're talking about all the servers, the power, the hardware you need to run these giant AI models. That's just an insane amount of money.
But, and this is the crazy part, you look at the actual market for the AI apps that use all that gear, it's only 5.6 billion. Not 57, but 5.6.
Yeah, you heard that right. That's a 10-to-1 gap. It's this huge paradox at the very heart of the AI industry. Think about it. We're spending $10 on the engine for every $1 the car is actually making right now. So what gives? Why is this happening? And more importantly, can it even last?
Well, the whole thing comes down to one giant bet. The entire industry is basically gambling that these massive, centralized large language models, LLMs, are the only game in town. The idea is that these huge brains are going to power literally everything one day, and that's what's supposed to justify spending all that cash up front.
But a new paper from some researchers at NVIDIA is starting to question that whole idea. They're suggesting this entire bet might be, well, a little misguided.
The paper makes a claim that's pretty bold and straight to the point. For a specific and really fast-growing type of AI, they argue that small isn't just good enough, it's actually better.
So what exactly are we talking about here? Agentic AI. This isn't just about chatbots. These are AIs that act like agents. They actually do things. They use tools like booking a flight for you or analyzing a spreadsheet to get complex jobs done.
And this is where the whole size thing becomes so important. Your big LLMs, they're the ones that need those billion-dollar data centers to even function. But small language models, or SLMs, they're so efficient they can run right on your laptop or even your phone. I mean, that's not just a small difference, that's a total game changer.
Okay, so why on earth would these smaller models be the future? The paper really breaks it down into 3 key arguments for why small models have a serious advantage.
Okay, so first off, they're way more powerful than you think. I'm talking about models like Microsoft's 5.3, which can go toe-to-toe with LLMs that are many times bigger, at least on specific jobs. Number 2, they're just wildly economical. We're talking 10 to 30 times cheaper. Cheaper on energy, cheaper on cost, and faster response times. And finally, they're incredibly flexible. You can tweak an SLM for a new task literally overnight. Not in weeks, but overnight.
So this is a great way to see how this all works in the real world. An AI agent, it turns out, doesn't need one giant know-it-all brain. Instead, think of it like a team of specialists. You can see it uses these small, fast models, the SLMs, for all the everyday routine stuff. Then, and only then, does it call in the big guns, the expensive LLM, for that one little piece of the puzzle that needs some heavy-duty thinking. It's about using the right tool for the job, And that saves a ton of money and energy.
Now, I know what you're probably thinking right now. It's the biggest, most logical pushback to this whole idea. And believe me, the paper tackles it head-on.
Right? It's the elephant in the room. By going smaller, aren't we losing some kind of deep understanding or just raw intelligence? Is that a trade-off we can actually afford to make?
This table lays it all out, contrasting what everyone believes with what the paper says is the reality. So first, this idea that LLMs have a better general grasp of things. The paper argues that for AI agents, that's kind of overkill, because they break big problems into tiny, simple steps anyway. Second, what about the famous scaling laws that supposedly prove bigger is always better? Well, the rebuttal is that those laws are based on old tech. New SLMs are just way more efficient for their size. It's like comparing a gas-guzzling 1970s V8 to a modern hybrid. And finally, the argument for economies of scale with big central LLMs. Turns out, fine-tuning a small, specialized SLM is so ridiculously cheap and fast that it totally flips the whole economic argument on its head.
Okay, so if the case for small models is so strong, how does a developer actually make the switch? This isn't just a bunch of theory. The paper actually provides a practical guide.
Yeah, they literally lay out a 6-step recipe. It's pretty straightforward. You start by just watching and logging what your current AI agent is doing. Then you look for patterns. What are the repetitive tasks? Is it constantly summarizing emails or formatting spreadsheets? Perfect.
Once you find one of those, you can train a tiny, super efficient expert SLM to do just that one job and do it perfectly for a tiny fraction of the cost. You're basically building a whole crew of specialists instead of relying on one expensive, overqualified generalist for everything.
So, the paper's final message is pretty clear. Look, the promise of AI is obviously huge, but the way we're doing it now, just burning billions on bigger and bigger infrastructure, that might not be the only path forward. What this research really points to is a future that could be more spread out, way more efficient, and honestly, more accessible to everyone. So the real question isn't just about the tech anymore, it's about the strategy. Are the big players going to keep chasing size, or is the next real breakthrough going to come from someone who had the guts to think small?